Okay guys, I'm here in the lab. I'm taking a little break to respond to a recent video by Nick Norwitz and also BioLayne's recent appearance on Breaking Points, arguing that maybe eating linoleic acid, consuming polyunsaturated omega-6 fats found in soybean oil, found in corn oil is fine, right? Maybe. Why? Because in short-term clinical studies, you don't see, or short-term dietary trials in humans, you don't see inflammation, as if that was important. Let's talk about what is important. So this is a 15-year-old study, right? This is not breaking news. This is very old science. Erythrocyte membrane phospholipid fatty acids desaturase activity in dietary fats in relation to risk of type 2 diabetes in the EPIC Potsdam study in Europe. This is done in Northern Europe. They don't consume a ton of linoleic acid. And what they looked at was, okay, if you have high amounts of circulating linoleic acid, are you more or less likely to develop diabetes? And the answer is that if you have high linoleic acid, you are less likely to develop diabetes. And I've been saying this for years. Of course, that's what they find, right? And so what they looked at here is the relationship between dietary linoleic acid and linoleic acid that they see in phospholipids in your blood. And what they found is the correlation is not good. The correlation was about 0.21, right? So that means that 21% of the variation in linoleic acid is caused by your diet, and 79% is caused by something else, presumably enzymes, right? And the biggest finding of the study was that if you have high delta-6 desaturase activity, delta-6 desaturase is an enzyme called D6. It's also called D6D, also called FADS2. It has a lot of names. And what it does is it converts linoleic acid to arachidonic acid, or it's the first step in doing that. And if you have high activity of that enzyme, okay, people in the lowest group, the lowest activity of D6D, 47 of them developed diabetes over 5 years. People in the highest group, 264 of them develop diabetes. And so you have more than a 5x risk factor if you are converting a lot of linoleic acid to arachidonic acid, which sits in the membranes and then can be converted to oxylipins. They circulate in your blood. They can be eliminated in the urine. Now, you look at obese or diabetic humans, they have high circulating levels of omega-6 oxylipins, okay? So the linoleic acid is the fuel that is being converted by delta-6 desaturase into oxylipins, and they did something called a Mendelian randomization study in this study. That's if you can't do a long enough controlled dietary trial with enough humans, the next best thing is Mendelian randomization. Of course, it's not perfect. Nothing's perfect, but it showed that this conversion of linoleic acid to arachidonic acid was causal in the development of diabetes in humans, okay? Now, furthermore, they did a follow-up study later showing that if you have the variant of the D6D gene that is higher in activity, you're converting more linoleic acid to arachidonic acid, you are more likely to develop diabetes. So that is, again, that was Mendelian randomization. That suggests causality, not just correlation. And so there's a ton of evidence in humans that linoleic acid is literally the fuel that is causing diabetes. Why? Because linoleic acid is literally the thing that D6D is converting. And then people are like, oh, well, yeah, but if you have high linoleic acid, that's correlated with better health outcomes. So consuming linoleic acid is good. No, you have high linoleic acid because you're not converting it to arachidonic acid. You want to go ahead and eat more of the thing which is driving your metabolic dysfunction, the linoleic acid, which is feeding into delta-6 desaturase. Sure, have fun with that. Go ahead. Then we got all these people saying like, oh, right, it's linoleic acid causes inflammation, right? It causes reactive oxygen species. It oxidizes, right? It oxidizes to 4-HNE and the other lipid peroxides, and that kind of inflammation. This inflammation is a sort of a nonsense word. It means 100 different things depending on context, but they say that's the problem. Okay, well then why does if you take a mouse and you use a pharmaceutical inhibitor of glutathione, which is the fuel for the body's master antioxidant enzyme, glutathione peroxidase. If you give mice a drug that prevents formation of glutathione, you prevent obesity, and you prevent diabetes, and you prevent metabolic syndrome. If you knock the enzyme glutathione peroxidase out of a mouse, right? So this glutathione peroxidase is the enzyme that prevents the kind of like oxidation of linoleic acid by reactive oxygen species, right? Glutathione is the fuel for that. So if you eliminate the glutathione, if you eliminate the enzyme that prevents the auto-oxidation of linoleic acid by reactive oxygen species, you prevent the obesity, you prevent the diabetes, and you prevent the metabolic syndrome. So what is it? Is it that vegetable oil causes inflammation and causes, you know, all these problems? Oh, I'll throw one more at you. If you give rats long-term supplementation of vitamin C, causes insulin resistance. If you give rats long-term supplementation of vitamin E, causes insulin resistance, right? And I'll put all of these links to all these references up at fireinabottle.net. I'll repost the video over there. Yes. Linoleic acid causes diabetes via its conversion to arachidonic acid by delta-6 desaturase. Why? Because all of those reactions, all of those two reactions, D6D, D5D, cytochrome P450s, oxalate, they're all using oxygen in the cytoplasm. They're competing with your mitochondria for oxygen so that you can effectively burn your fuel. That's what I think. But we can see that linoleic acid is implicated in the development of diabetes via it being fuel for delta-6 desaturase. Assuming that two people are eating the same amount of linoleic acid, when you see your blood levels of linoleic acid begin to drop, you are in trouble. And that is perfectly consistent with the message of don't eat linoleic acid, the fuel for diabetes.